This is a video for Math 117, Section 2.3, Part 2. I'm going to skip past question 1 and go directly to 2. Question 1 is a little easier version of it, so if you'll start there, it might make it easier to do this one also. So we have to graph these three pieces, and then we have to figure out a ratio. Now, f of t is the ratio of working age population. So when it says ratio here, it doesn't mean you have to find a fraction. It means that you want to figure out a function value given these three pieces of the function value. Now to work with a graph here, I'm going to need pieces that have endpoints. So I'll need to have pieces like this. So you first open up this little layer, and I want it at 4.1 and going straight across. In the graph layers, I have no idea where I put that, so let's figure out where that first layer goes. The first one is if t is equal to 0, y is going to be 4.1. So this should be 4.1. That's my first point, and this should be 0. And notice the point moved to be at 0, 4.1. And then the next point will be at 5. That's where the other endpoint is, 5 and 4.1. The first one needs to be closed because it's less than or equal to, so we'll put closed. And the second one needs to be open. And it looks like I picked the wrong one here. So this one's closed and the other one is open. So the one that's highlighted is the one that's being used. Closed, open. For the next one, I need to use the slope to be able to do this. So maybe on my calculator, I'll figure out where the points are supposed to be. So I'm putting 5 in here. Let's go to my calculator. Second quit. I'm going to store 5 into x. And then I'll do negative 0.03x, negative 0.03x, plus 4.25. Now, you could have done this maybe easier some other way, but this works just fine. And I get 4.1, so it's actually going to close in on that point there. And then I need to know what happens at 15. So 15 stores to x. I only have 2 points I'm putting in here. And then I can go grab this either with a second enter, like this, second enter. Second enter will take me back up, or I can scroll up if I have the updated operating system. So putting 15 in, I'm going to get 3.8. So I need these points, 5, 4.1, and 15, 3.8. So I need another graph, 5, 4.1, and 15, 3.8. That one I might have gotten pretty close. So I'm going to open up my segment 2. I need a closed circle on that, open circle on this one. 3.8 I think was what this was. What was it, 4.1? It was 4.8, 4.1. 4.1, and it was at 5. So 5 and 15, and this was 3.8. Let me get rid of any of these decimals back here. So that's what it actually should be, and that looks good. Okay, now I need a third segment, and that's putting 15 into the third segment on my graph. I could have graphed this in y equals and done it that way too, but I can also do it one piece at a time. What this means is the endpoint of 15, and right now 15 is stored to x, I can just type in negative 0.075. Be careful with your zeros here, because it's really easy to miss putting one in. And I'm using x instead of t, plus 4.925. My calculator always uses x's, and I end up with 3.8. So it looks like this one's going to come straight across. No, it's going to start at 3.8, so I still need to put in 35, the last one. So 35 stores to x, enter. And then it's second entry. To get back up to my equation, hit enter. I have 2.3. So I need 15, 3.8, and 35, 2.3. 35 is up here, 2.3 is about here, so I get it pretty close. somewhere I messed up there. So this is 15, 3.8, and this is 35. What was it? 2.3. I need both closed circles on both of them. So I need closed circles on both, so I'm good with that graph. So I'm done. So this should be the whole graph. That looks a little funny. Yeah, but that looks right. Oh, I just need to click the graph there. So then I'm going to put the correct numbers in here, and this is really an exercise in which t am I supposed to use. So t equals 0 is 1995. So t equals 5 would be 2000. 2003 would be 8. So t equals 8 puts me in the second piece. So I'll put 8 in there in my calculator, just like I've been doing for any of the other ones. And then 2014 would mean putting 14 to, well, you could just do 2014 minus 1995. And that'll give me, I'm going to put 19 in, which means I'm putting 19 into my third piece. They ask you a couple of questions concerning the graph. If a ratio is constant, in this case that's the y value is constant, that would be a horizontal line. So looking back up at the graph, which part of this was a horizontal line? For the second part, it says, over what years is the decline of the ratio the greatest? Well, the decline greatest would be the steepest slope. So looking here, which one of these looks like it has the steepest slope? Well, you can actually tell that here, because the number in front of the t value in the equation, the t variable rather, whichever one is the biggest one is going to be the steepest slope. And they're both going down, they're both negative slopes, so it's declining. For the next curve, I just need to put this in my calculator. So let me put x equals, what is it? P equals square root, second square root, and that's above the x squared down here, of 25 minus x squared. Now if you have a TI-83, you probably want to close the parentheses there. I noticed that this is not going to be my standard grid, so I'll go ahead and graph this. It gives me this graph, and I can get a pretty good idea of what this is supposed to be. But let's put it on the window the way that they've shown the graph in here. So the window goes from, I usually do 1 less to 10. That looks good for the x. And they're given tick marks every half, but this is fine. 1 is fine. I'm going to go from -1 to 10 here and graph again. So there's what my graph looks like. Theirs is a little bit more square than mine, so it may look more like a circle than a parabola, than a half a parabola. And it should look like a circle because this actually is half a circle. Now remembering that x is the quantity and p is the price, they're giving us a y value of 4 here, and we want to determine the quantity demanded when the y value is 4. So I'm going to put in the y is 4 here and graph. You can see that what it's actually asking for is an intersection for when y is 4, not when x is 4, when y is 4. So if I do second calc and find the intersection 5, first curve, second curve, and the guess, it's going to give me the intersection is at x equals 3. Question number 4 was worked the same as number 3. And all of these, 5, 6, and 7, are finding the market equilibrium given a supply and demand equation here. So you're going to do the intersection for each of these. And I guess I'll do one of them. I'll do number 6, just because. So I'm going to go to y equals, I'm going to put in clear, have 47 minus 4x squared. Most likely the difficult part of this, or the challenging part, will be getting your units for the window right. So we need for the second one x squared plus 15x plus 27. Now I know I'm not interested in any negative quantities, so if I graph with my -1 to 10 here, and I get a nice graph, then I'm really done with this. But I can't really see what's going on there. It looks like most likely it's going to cross somewhere in here. So from -1 to 10, if I do a zoom 0, you can see that says zoom fit. This is an important thing to do here. You end up playing with this a long time. Zoom 0 is going to fit the graph so that I can see the interesting parts on the graph. All I want is the equilibrium quantity and price, and that's where the supply and the demand are the same. I'll ask you that question. Where do you get the equilibrium? It's where the supply and the demand are the same, or where they intersect, whichever way you want to say it. So we'll do second calc. We want an intersection, that's 5. First curve, second curve. And you can move a little closer if you're not quite sure here. So I'll move pretty close to where the intersection is, and I can see that my intersection is when I have x equals 1. In this case, 1 is in thousands, and it says so in the problem. So x equals 1, and my y value is the price, is 43. So this company should set a price of $43 and make 1,000 units to have supply and demand be the same. Market equilibrium. 6 and 7 will work the same way, but number 8 is an area problem. So this goes back to geometry. So Patricia has a rectangular garden and she has 96 feet of fence and she's going to enclose her garden. She hasn't decided where the garden's going to be, but she needs to figure out some variables. So if she lets x be the width of the garden, y is the length, we want to find a variable, a function f, that will give us the area. So let's take this one to paper. So because we have fence, that's like going around the outside. So we have x and y. So we actually have a perimeter is equal to 2x plus 2y. You might remember this formula from Algebra 1 or Algebra 2, or maybe geometry. So we have 96 is equal to 2x plus 2y. Now if you remember the area for a rectangle, that's the length times the width, so this would be xy. But I want a function that only has x in it, so I need to solve this for y and put it back in here. So I call this juggling equations, juggling pieces of information. So we have 96 minus 2x, subtracting 2x from both sides, is equal to 2y. So that gives me that y, if I divide everything by 2, is 48 minus x. So in here, I'll put 48 minus x, and that tells me exactly what I should have in WebAssign for my formula. Now the domain is basically what's going to make each of these pieces 0. So the smallest x can be a 0, and then the smallest that this piece here could be, well, the largest this piece here could be is if x is 0, it would be 48. And vice versa, if this is 48, this would become 0, and then that would be 48. Now x can't actually equal to 0, so I think the domain here should not include the endpoints. If x was 48, we'd have 48 here, 48 there, and that'd be our whole fence, and we wouldn't have a rectangle. So the domain should be 0 to 48, not including the endpoints. Determine whether the statement is true or false. A polynomial function is a rational function. So a rational function could have a denominator of 1. So polynomial could be a rational function, but a rational function isn't always a polynomial. So here we have a polynomial function that's also rational in the first one. In the second, this is a rational function, but it's not a polynomial. Now the word converse means that if you say the sentence backwards, and I think one of the ones that you might have heard in geometry was, a square is always a rectangle, but a rectangle is not always square. So you can say a square is a rectangle, and that's true, but a rectangle is a square is not necessarily true. So you want to consider that. Some of these, the polynomial functions are combinations of rational functions, and polynomial this is backwards, so just thinking about what that should say. In question number 10, 2 to the x is actually what we call an exponential function. X to the r is what we call a power function. In numbers 11 and 12, I would recommend you put these in y equal and find the table to use the table to find the values for these particular numbers. It's not asking you to look at graphs, so you really don't need to look at it. You just need to set up your table to start at 0 and then figure out which years corresponded. T equals 0 is 1997 here, T equals 0 is 2003 here. Number 13, they also want the graph. So it's a lot like the previous problem, but they want you to be able to look at the graph here. So let's put the graph in, and I'm going to set my window to be from -1 to 5, and then do a zoom 0. You can see what my graph looks like. Notice here that the window, will give you an idea, this went up to like 70. So my high point was around 71. Well, it wasn't really, because if I look at the graph, it was somewhere in here. So that looks like it's even lower, maybe in the 50s. So if I go down and look at my graphs, you can tell which one it matches with pretty easily. The next thing they want me to find is the maximum and the minimum. So here, the maximum and minimum have to occur between 0 and 4. So I'm not interested in the entire maximum in my window or the entire minimum in my window, just between 0 and 4. So I would do a second calc, and I want to find minimum. Well, let's do the maximum first. I want to find the maximum, and I want it on my entire interval from 0, and I can just put in 0 to 4. Now what this does, when you put in these two numbers, is it puts little arrows here so that you can see I'm looking between here for my maximum. My maximum should occur here at x equals 0. So if I hit enter, because it's asking me for a guess, if I hit enter, it's going to give me my maximum occurs if this is the number 0. See the -6? That's 1 over 5,000,000. 6 zeros. So that's a really small number. So this is 0, and the value there would be 50. Alternatively, if I put in second calc maximum 4 at 0, and then at 4, because that's where I'm looking, I want to guess at 0, enter, it's going to give me 0. So sometimes it's helpful to go ahead and put a 0 in there to see that endpoint, because it'll give you funny looking numbers if you don't. If I want the minimum here, I'm going to do the same thing. Second calc, minimum 3. Left bound is 0, right bound is, and I could have put 3 instead. See, it's between 3 and 4. So I could have put 3. Right bound is 4. Could have cursed over. So now it's in between 0 and 4. And it's giving me the minimum occurs at 3.366795. So notice that here they're asking me for which decade. So this was the 0. And I really didn't need an exact value here because the minimum occurred between 3 and 4. So I kind of overworked this problem, but I also gave you a little bit more insight when you actually have to know what that minimum value is. So I just need to know which decade this was in. So be really careful. 1960s would be the first decade here, 60 to 70 to 80 to 90 to 2000. So just read the graph carefully. Now I'll remind you of the table, second table set. If I set it to 0 and the delta table of 1, so that's setting up the table, and then look at second table, then I get values in there. Now, on this graph, they're actually asking to 1 decimal place. So all these give me 1 decimal place. So make sure you're rounding correctly here. The last couple of problems here are just exercising your calculator. So we have a few ways we've done that. We could go into y equals and put the formula in. We could quit out of there and store to the value, whatever 2004 was, according to what the 0 is. It says 0 is the beginning of 2002. So we could store our x and then put the value in. Or we could do y equals and do a table set. So we have at least three different ways that we could figure out these values. This one is piecewise, and we know how to put piecewise in, but you could do them one at a time for the values.